Definite challenge question today. This is a good question for, it's a good honors level word problem. So get right into it, guys. Make sure that you put the date and that you answer in your notebook. Before I start going over it, I'd like for you to just read it. I'd like for you to read it before I start going over it. I'll be honest with you, it's less straightforward than some of the problems we've been doing. It takes some creative thinking. I'm not going to give you exact perfect steps for it. It's kind of one of those things that you just problem solve through. So try reading it. You about put your phones away. Dennis, put your phone away. For now. You got it. There's a lot of talking in here, and it's not about tuberculosis, so be quiet. The yellow one, then. No. Lois, play stop. Okay. All right. So, tuberculosis is a disease that's not as big of a deal in the U.S. anymore. I thought maybe we all got vaccinated on it, but we don't. Nurses who work like in the trauma center, they have to get vaccinated. If you leave the country, a lot of times you have to get vaccinated for it. And then young children in other countries are typically vaccinated for it. It's like a lung thing. The bacteria gets in your lung, and then you have a hard time breathing. But I think it was like a full pandemic in the early 1900s. Anybody? Anybody got any knowledge about tuberculosis?
Like it was very common if you like went on a boat.
Oh, when people were traveling on ships.
Get it, and then they would go somewhere else and it would spread it to them.
Okay, right. I remember reading about it in history.
Yeah.
Okay, now surgery too.
I think it was also
That's not my water.
Alright, so here's our function, okay? Now typically with the PERT function we talked about yesterday, P is the initial amount. Now the way they've written this, they have the initial amount indicated as A. That's normal. Sometimes the initial amount is A, sometimes the initial amount is P. What's not normal is that we don't know what the initial amount was. They haven't told us how much bacteria we're starting with. It says this is the number of bacteria after T hours. A is at 12 p.m. It does give us this important information. It says at 1 p.m. there's 30 bacteria. Find the number of bacteria at 3:45. Now I'm just going to wait on this portion. I'm going to solve this later. First, I need to figure out how many bacteria there were at 12 o'clock. They've kind of left that important bit out, so that's where the the problem solving of this word problem comes in. We need to find A. We need A to make our function complete. So we're going to use this data at 1 o'clock. There's 30 bacteria. So we're going to use after 1 hour, 30 bacteria. That's kind of like an ordered pair. Okay, it's kind of like saying 1 comma 30. If we were to visualize a graph and all that. So 1 is the T, and 30 is like the Y value. So I'm going to rewrite this. I'm going to use 1 and 30. I'm going to put 30 in the result. Don't know A, I wish I did. E is a number, 2.71. This is a button on my calculator like pi. It looks like a variable, but it's really just 2.71. That's a number. That means that the bacteria is continuously growing. The most accurate calculation is using this number because it's continuously growing. There's no breaks in the growth of the bacteria. It's growing a little bit. And the amount it's growing is 16.6% each hour. So I know this is the rate in the PERT formula. So if I was to move the decimal, it's growing 16.6% each hour. Okay, I'm going to put the T out. And since after 1 hour is 30, I'm going to put 1 in. This is going to help me find A. So I'm going to break down, I've set this up for you. I want you to use your calculator here. Divide, find A. I'll give you a minute.
I'm so confused. Why did it update overnight? It didn't look like that yesterday. My interpreter did not look like that yesterday. I didn't know this
On this?
No.
Her calculator.
My calculator's all that stuff. Something
Like,
happened. Please reset it. Not even listening. Don't wait.
What? What did you say? I wasn't waving.
I'm not remembering my calculator.
Level up. Okay, so I'm gonna put all this in my calculator. This e to the 0.166 times 1. And I got 1.18 and it goes forever. I'm gonna leave that whole thing in my calculator. I'm not gonna round it. I'm gonna try to use that just like it looks. But when I write it down for you guys, I got 1.18. Okay. This goes. So I'm leaving all of the data in my calculator, but this is what I'm writing down. I am now going to divide. So in my calculator, I'm going to do 30 divided by this. So I'm going to go up and I'm going to highlight that whole decimal and I'm going to do 30 divided by that whole decimal. I can tell you how to reset it. I think it says reset just over the 0.
Oh, recall?
No, that's not what I meant.
Over the 0. Okay, I see it now. Thank you. I see that.
Alright, so the A value is about 25, which I'm going to think, does this make sense? Does it, after 1 hour there was 30 bacteria, does it make sense that times 0 at 12 that there was only 25? Yes, it does show growth. So we're actually starting with 25 bacteria, and then by 1 o'clock we're up to 30. So that feels like 1/6 amount. About 16% growth, okay? So now I'm going to rewrite using A. I'm going to rewrite the formula with the A that we calculated. We used that one piece of information. equals 25.41 times E to the 1.66 times T. And typically, if you're asked to write an equation, you're asked to then use the equation. So now I'm going to go ahead and hit up this part that I said wait and solve later. Now that I have the equation with the starting amount, I'm going to try to figure out at 345 how many bacteria there are. So I'm going to give you guys a minute. How do you plug in 345 into this equation? It's actually starting with 12. So, yeah, it's like times zero. What are you going to put in for T, guys? Listen, if 45 minutes have gone by, are you over half an hour?
No, you're. Oh yeah, you are.
Yeah. 45 minutes is quite a bit of an hour. So I'm not actually gonna put. I'm maybe gonna put 345 when I was in your shoes, but now I'm thinking about 345 in a different way. How much time is 3 hours and 45 minutes? It's 3 3/4. It's 3 3/4. 45 minutes is 3/4 of an hour, right? So actually, when I'm putting in my t value is 3.75. It's been 3 hours and then 0.75 of an hour. So that's kind of an important conversion. Minutes are not really helpful when you're talking about hours because for some reason our hours and it's 60 unit instead of 100. So when you're plugging it in, you need to think, well, how much of an hour is it? It's 0.75 of an hour. 45 minutes is 0.75 of an hour. Okay, so let's finish this challenge question up.
Wait, I got this.
Okay, I'm glad. He's actually about
Miss Baldwin, is this right?
47. It's about 47. That is right. Yep, here we go. And then write your answer in a complete sentence. 47.36. I'm going to round that. So at 3:45 p.m., there are 47 bacteria. Wash your hands, people.
I had to wash my hands.
Well, this is what mine looks like: 47.356618251. If yours is different, it's probably because you put this number in. I kept the whole decimal in my calculator, and I went up, highlighted it, and grabbed it. Okay. So if you're a little bit different right here, it's just because you rounded at a certain spot. As much as possible, I try to store the whole decimal in there, especially when I'm working with something like E, which is an irrational number. And I go up and I highlight it, hit enter, and I grab the whole thing instead of using that rounded number I wrote down. All right, any questions on this word problem? Mostly, guys, I want to jump into the idea that A is really important. At the spot in either, whether you want to call it the A spot or the P for principal spot is very important, the initial amount. And that E is a button on your calculator. That's mostly the point of all of this. And that the compound continuously very much applies to our real scientific world, things like bacteria. It is used in chemistry and biology and things like that. So let's check yesterday's assignment. I would like to look at 35 first. I looked up this tritium. I feel like I might be saying it wrong. Tritium? Tritium? What do you guys think?
I don't pronounce that word. It doesn't sound
Tritium?
I think they made it up.
So it's the byproduct of like nuclear waste. Like you go to a nuclear power plant and they say like nuclear energy is cleaner than fossil fuels, but it does create this byproduct that we're kind of burying in the earth, and that if anybody in the future uncovers it, it's very toxic. It's really dangerous. But it only produces a little bit of it. But anyway, what it produces is this tritium, and it glows. So we used to use these things. It's like a glow in the dark. You guys have seen The Simpsons, where the little like fluorescent thing comes out of the factory and it makes this three-eyed fish. That's what we're talking about here. So anyway, oh here it is. We looked it up last class. Tritium is used in boosted fission weapons and thermonuclear weapons. So there's certain policies against using it. But it used to be used a lot in glow-in-the-dark lighting, exit signs, things like that. And this says it's used in biomedical procedures to figure out heart disease. Like maybe they put it through the body and then they can see if there's blocked arteries or veins. So
That sounds really unsafe. I just said it.
yeah, here's where it says it. It's also used as a tracer in biomedical research to diagnose heart disease, cancer, and AIDS. Well, maybe I'm wrong about this. Maybe it's just something they put in the blood sample.
I don't know.
Either way, it's a real thing. It's really out there.
How can you look it up? How do they use?
Let's not.
Alright.
Good try.
Oh my god.
Okay. So anyway, in this problem, you're comparing this equation for the tritium to this graph for the sodium. So don't think that the graph goes to this equation. They're two very different things. The initial amount in this graph is 10, whereas the initial amount in this graph is 15. So starting out, there's more sodium. This is how sodium decays versus how tritium decays over time in years. So it's negative because it's decaying. It's decaying 5% every year, this tritium. And sodium, we don't know. They didn't give us the equation, but all right. So for 5 years, I put 5 into the equation, and there's approximately 7.5 milligrams of tritium left. Whereas when I look at the sodium graph, after 5 years, there's only 5 milligrams left. So even though sodium started with more, after 5 years, there's less remaining. So it must have a higher rate of decay. And tritium started with 10, but after 5 years, there's still like 7.5 left. It's still there in a good amount. And that's that. Any questions on 35? Comparing the equation to the graph. So it's clean water this time. Just kidding. All right, here's number 33. This is interesting when I think about financial advisors. Okay, some financial advisors specialize in daily investments and yearly investments, whereas some financial advisors specialize in like retirement, which is I'm going to invest for 15, 20, 25 years. So this account, after 5 years, the account earning 3.8% continuously earned more. but and it started with 3,000. But letter B starts with less money, has a higher interest rate. After 15 years, it passes the one earning interest continuously. So financial advisors, they kind of specialize. Well, we have to know how long you're planning on investing this amount of money. Are you planning on investing on it 1 to 5 years? Then we want this interest rate with this type of compound. But if you're willing to keep this in here for 15 years or longer, we'll put it in this account. It'll earn more over time. So when you have a retirement fund, like all of us working professionals, we put money away every paycheck. So every 2 weeks, hundreds of dollars go into this account. I cannot take it out. We are not allowed to get that money out. They keep it for 20 years, 30 years.
If you're homeless.
Yeah. If you lose your job, there's a financial crisis, and you want to pull your money out, they charge you. So they can keep like 75% of it.
Oh, heck no.
They're like, you can't have it. So if you try to retire early, you can, but they're going to keep a good portion of your money. So when you get older, that's a really good motivation just to keep working because the wealth really builds at the end of the time. So anyway, there's certain places that you invest money where you're really not allowed to take it out. If you try to take it out, they're gonna charge and keep a good portion of it. You can get it, but you don't want to. You'll lose most of your investment.
Yeah, that sounds pretty good.
So that's the difference between like a savings account, 401k, if you've ever heard of that, 403b. Your savings account, you can take your money out, that's yours. But a 401k and a 403b, the government is also investing that, and you can't take it out. You'll learn. 403b is for nonprofit. If you work for the government or the public sector, it's called a 403b instead of a 401k. There's different rules. Yeah. All right, and here's number 34. You guys, just so you know, I'm not testing you on simple interest. I really don't care about letter B, but I want to know, can you get letter A out correctly?
I do. I think it's important.
All right, I'm gonna walk around and do you have a question? Yes. So I'm gonna walk around and give you credit for doing this. You guys are gonna start writing these notes on logarithms. So we're starting chapter 6.3. It's on page 564. Go ahead, read through this and think about it, and then I'm gonna do a quick laugh and give you credit for your word problem.
Okay. The whole is with the expense, so we're.
Log, like on the thing,
A stick? Like a bigger stick?
like log, like
Yeah.
log.
Oh, what page is that on there?
Don't put it in the basket, just put it on my desk.
Oh yeah, this is easy enough. All you gotta do is push the button.
No, you have to press it twice.
So yeah. Make your notes, Alexis.
What do we have to write? Oh, Kylie. I was chatting it up with the boys, and Tristan and Kel said that they'd actually be up to do studying. And Kel said, she's like, if you guys were all there, I would actually love to freak out. He did tell me that he's like, I make her back.
And I'm not being the bigger person.
He was like, just no. I made her really happy with that way. She made a face at me. I was like, probably. I was like, oh, okay.
Still salty about it.
Yeah. Kristen was like, what'd you do? What'd you do? What'd you do? I was like,
Okay, I keep on responsibility.
less than a week.
Right.
Good thing tests aren't until.
We're gonna lock in for another 2 weeks.
I can put those answers up for you here when I'm done. Okay. Let's get into logarithms for a moment. Okay, so I walked away, you guys, but I didn't. Me too. Alright guys, so it's important with logarithms that you, it's kind of a new word to you, but logarithms solve for unknown exponents. Today you're just kind of learning equivalent expressions. So if you have an exponential equation like b, variable b to some exponent x equals y, that is the same as saying log base b of y is x. This is called a subscript. It's down low, opposite of an exponent. So this one looks really obvious, right? The way this is read is log base 5 of 25 is 2. That's the same as saying 5 squared is 25, which we know. We know 5 squared is 25. So someone last period said something really insightful. They said, why would you take something like 5 squared is 25 and make it complicated and writing the word log? Why would you do it? So what I want you guys to know is that really this isn't the real use of a logarithm. Logarithm is really used for something like this. It's really used for more of this scenario. Okay? What would x be here? 5 to what power is 13? That would be like a guess and check situation. So when we were doing finance and I said, well, after how many years would the car be worth $500? I said just guess and check in your calculator. We're moving past the guess and check phase into finding the exact number. So 5 to the first power is 5, and 5 squared is 25. So this must be some decimal in between 1 and 2. Maybe it's 1.3. Maybe it's is it 1.6?
Yeah, 1.6.
So to the 1.6. Now, scientists want to know that exact decimal that will give you a 13 out. So what they'll do is they'll use a logarithm. So today, you're going to do logarithm facts with stuff that's real basic, like 5 squared is 25. But we're moving towards something a little more complicated, like this. Okay? So right now, go to page 564. We're going to do the gray box problems 1 through 6. See if we can figure out just for your writing. Hey, can you do number 1? Yeah, the gray box. 564. Let's take a look. You're going to use this one example to help you with the first part. One Alright, so, and you can use, I encourage you to read 564 and all that. But here I'm going to go through number 1 with you, okay? Alright, this thing is called a subscript. Log base 3 is the subscript. This is going to be the base. So I'm going to write a great big base 3. Logarithms solve for exponents. So what it's equal to, and you're going to want to draw an arrow and label this so you This bit is an exponent. So that's 3 to the 4th. And the very last number, the 81, that's called an argument. That's going to be the result of the exponential equation. And you can always go back and see what you've written and say, does this make sense? Is 3 to the 4th power really 81? 3 times 3, yes, yes it is. So this is a thumbs up. How we've rewritten it is true. You got your base logarithm solve for exponents. That's the exponent, and that is going to be the result. Okay? I'll do one more, and then you guys do the last two. This is the base, and this is the exponent. 7 to the 1st is 7. True. Now they get more complicated. We're going to start seeing fractions and decimals and negatives. So I don't want you guys to speed through the simple ones. The more you understand the simple ones, the more you're going to be able to tackle the more complicated ones. So you guys, I'll give you a minute to do 3 and 4 on your own.
What?
Really?
Jake, are you in this? What's number 3, Jake?
14 to the 0 power.
That's true. Anything to the 0 power is 1, so that's true. This is like the zero property of logs or whatever. If you have a 0 power, then the argument will always be 1. That's fun to sit and think about. Okay, and then this last one. Jakeem, this last one's a little weird, right? Number 4 here. Yeah. Let's look. I know it's white coat on you. I want you to think about it for a minute, okay? All right, you go ahead. Put it in exponential form for me. Yep, 1/2.
To negative 5th power.
Yep, because it's a fraction, guys, I'm going to use parentheses. Now, does this make sense? Why? How do we do negative exponents? This would be 1 to the negative 5 over 2 to the negative 5. Negative exponents lead to reciprocals, so this will go up and this will go down. So this is actually 2 to the 5th over 1 to the 5th, which is in fact 32. All right, so keep in mind that all of the properties of exponents are important here. Okay, fractions can turn into whole numbers with negative exponents. So this does make sense. That checks out. All right, the next we're gonna do 5 and 6. Those are a little less natural, rewriting them. So here's some steps if you'd like. For rewriting in log form, if you like writing steps down, this is for you. You start with writing the word log. Now, lots of mathematicians are severely irritated with this word log because why are we all of a sudden writing words in math, right? Like, we don't write the word add, we don't write subtract, we don't write divide, we don't write exponent, we don't write factor. Why are we writing the word? They should have just made this a symbol because it's just a math operation. Okay? But they failed on it. Now we're writing the word instead of the symbol. So it doesn't have a symbol, it's just a word. So you start by writing the word log. Then the base of the exponent is a subscript down low. So this is the base 5, and I write it little down low. The argument goes next. So the 25 would be next. And logarithms always equal exponents. So the exponent goes out here. Log equals exponent. See, exponents are the result. Sometimes people see log and they think it says 10g, which is funny. And they think, where'd that 10g come from, Mrs. Baldwin? I said, well, it's supposed to stay log. All right, when you're ready, do 5 and 6 in the gray box. Start by writing the word log. Peyton, you can go. Oh, you already did? Who's going down?
You have to crush it twice.
Right there. What's that? Yeah, that's what I said. They house nice creatures. Sometimes they don't.
Inanimate object.
Alright, so I write the word log. The base is the subscript. I know that logarithms equal exponents, so it's going to be equal to 2. And then the last number that goes in the log is the argument 49. So I always have a real easy time putting the base in the right spot. Of course, logarithms equal exponent, so the exponent goes in the right spot, and that 49 fills in the argument. Who can do number 6? Okay, then.
Oh, I did number.
Who's gonna read it? Go ahead. You wanna read it out loud? Yeah. Yeah, what is it? Got it. Log base 50 of 1 equals 0. Because 50 to the 0 power is 1. Got it. Okay. Yeah.
4 to the 1/4 equals
4. Wait, you gotta say log.
log 4 to the 1/4.
I know log. Log 4, 1/4 equals -1. Exactly.
I'm proud of you, Libby. Good job.
Okay. So the last thing you're gonna have to do is evaluate, which is a little bit trickier. And the more time you understand the first bit, the evaluate comes along. So turn your page so you can see example 3. The most difficult ones for evaluate is when a fraction turns into a whole number. Consider negative exponents. If you got a fraction getting bigger, or even if you have a large number turning into a fraction, think of negative exponents. So for all of these, it just says log 464 and evaluate. I like to put in equals question mark, equals question mark, equals question mark, equals question mark. And that helps me remember what I'm trying to figure out is the exponent that will yield the argument. So for like letter A, I have to think to myself, 4, what power gives me a 64? 4 to the 3rd is 64. So the answer is 3 opposite 5. So what power gives me 0.2? What? I don't like 0.2. It's close. That's close. Now I don't typically understand how 5 relates to 0.2. So what I want to tell you is that when it comes to logarithms, fractions are actually easier. So you guys, what is 0.2 as a fraction? Yeah, how'd you do that? You just know it. Remember? What do you do? Yeah. So like 100 divided by 5 is 20. So 1/5 of 100 is 0.2. So that's going to be a little challenging here, but 1/5 is easier to understand than 0.2. So now I think to myself, 5 to what power is 1/5? And that's a -1. Okay. 5 to the -1 is 1/5. So if they're giving you a decimal, try to think about it in fraction form. It's going to be a little bit easier. So this is your negative 1. Letter C. Gosh, this one's challenging too. 1/5 raised to an exponent that I don't know is going to result in 125. Well, a fraction becoming a whole number is probably going to be a negative exponent, but what I do is I ignore the 1 and I focus on the 5. I know 5 to the third is 125. So then how do I get this 1/5 to turn into a regular 5? Negative 3. So we need a negative exponent there to turn a fraction into a whole number. These are going to be your properties of exponents. So you're doing 1 to 21. The first 2/3 are kind of just rewriting the more basic. Towards the end, you're going to get challenged with this evaluate bit. Use this example, read what the book has to say. Letter D. How does 36 turn into 6? Because it's a square root. Okay, so if a number's just getting smaller but not turning into a fraction, you're going to want to think about roots. 36 to the 1/2 is 6. Because the square root of 36 is 6. We'll work more on this tomorrow.